So we've been talking about domain and range, and it wouldn't be domain and range without talking about these weird breaks in these graphs, which the technical term for is discontinuities. So here are a few examples of these discontinuities. At the point 1, 3, that's this point here, there's a break in the action. That's referred to as a specific kind of discontinuity called a point discontinuity or a removable discontinuity. A removable discontinuity is the more specific version of a point discontinuity. So how about this point at -2, 1? That's another kind of point discontinuity, but we refer to it instead of as more specifically a removable discontinuity, where this point was technically removed from the graph. If we want to get more specific about this kind of point discontinuity, this would be a jump discontinuity. See how the graphs jump? So these names make sense for what we're looking at on the graphs. So both of these are examples of point discontinuities, and if we want to get more specific, this is a removable discontinuity, and this is a jump discontinuity. Okay, and another name for the removable discontinuity is a hole. So sometimes you guys will hear it referred to as a hole, and we'll get more in detail about these discontinuities later on this year. All right, here's another discontinuity, and this is probably a totally new word to you. So these dotted lines, we saw them on the domain and range example. These dotted lines are called asymptotes. Okay, so these asymptotes create a specific kind of discontinuity, which we call an asymptotic discontinuity. So sometimes we refer to a function as being continuous, and this happens if there are no breaks in the graph. So the functions up above here, these are not continuous functions. All three of these examples here have breaks in the action. So if you can draw a function without lifting your pencil up at all, then that graph is continuous. All three of these examples up at the top are not continuous graphs. Alright, so I mentioned before that there are different types of discontinuities. There's a point or removable discontinuity. That happens if a function is discontinuous at a single point. So these are really just like your two umbrella terms for two major different types of discontinuities. One type is a point discontinuity, the other one is an asymptotic discontinuity. That happens if you have a line, and the function above it was a dotted line, that the function gets really, really close to, but never quite touches it. So I always describe an asymptote as like an invisible dog fence that a dog gets really, really close to, but never really quite touches. So that's an asymptote. Okay, so let's look at all the different discontinuities in this graph down here. So I can see if I'm talking domain, because that's really, we usually talk about discontinuities just in terms of domain. So where are the x values where your function is continuous? Alright, so if you guys are looking at the domain, remember we read domain from left to right. You can see that the graph starts at x equals 0. So we've got a domain starting at x equals 0, and if we read from left to right, we can see that we go from 0 up to this point, up to x equals 1. Alright, I've got my first discontinuity here at x equals 1. Okay, so we can fill in our table at x equals 1. I've got my first discontinuity. Alright, so think about what kind of a discontinuity this is. What's happening to the graph? Is this a point discontinuity, or is there an asymptote there? We can see there's no asymptote, there's no dotted line. The function isn't getting right up close to a dotted line. So I know that this is a point discontinuity. So I'm just going to put a P in here for point. Specifically, if we want to get more specific than point, it's a jump discontinuity. Alright, so let's keep reading from left to right. We went 0 to 1, and now we're starting at 1 up here, and I'm tracing, and I made it to 2. We've just come across our second discontinuity. So this happens at x equals 2. Okay, and is this a point discontinuity or an asymptotic discontinuity? Well, what's going on there? There's no dotted line that the graph is getting close to. There's just a point. There's an open point and a closed point. So we can see that there's a removable discontinuity here. If we just want to be general about it, we can just call that a point discontinuity again, because it's not an asymptote. Alright, So we're reading the graph now, we're picking up at 2, and we're going on from there. So we get to here, and if we're tracing left to right, we get up very, very, very close to this x value, which is at x equals 3. We get close to it, but we never quite touch it. So we can see this arrow coming right up and hugging it, but never touching it. And then on the other side of 3, it goes on again, and we end up at 4. Okay, so there were lots of breaks in the action along the way. So our last discontinuity occurred at x equals 3, and that was an asymptote. That was where the graph got really, really close to this imaginary line. So you could actually draw in a dotted line if you wanted to, that the graph gets really close to. All right. So go ahead and think about if discontinuity affects the domain and range of a function. And what might be helpful is to go back and look at the domain video and the range video and see what kinds of discontinuities there were there. Or you can use what you've already learned about domain and range and look at the 3 examples at the top of this page.